In this session, we're going to look at how to install Assimp and how to work around uh, using that. Yes, the Assimp has ability to capture or the take in any format of a model and then convert it to a one common data structure so we can use it. So the reason that we learn about the 3D model and you did two projects on it, the reason you're doing that kind of project is just to understand the core uh, of the buffer loaders and how you're really going to use it. So that's the reason I just gave you two projects related to that, so that is, if you are able to do that properly, so you know have good knowledge in depth. So if you don't have that much knowledge, yeah, you can use something as Assimp. So one reason I'm going to point out this kind of a framework is there are so many image, I mean the model formats out there. So we have no time to learn every and each format, right? So this is a good way of learning that. So the Assimp help you to do that. So what is Assimp? Let me talk about that for a minute. So we can go to assimp.org. So this is the website for them, and you can see it has a documentation here, and you can go there. I mean, the certain documentations are there, so you can go and look at the structure and everything. They have some model database as well. I mean, it's on the GitHub, you can download that. That is not that important. The most important part here is Assimp docs actually. So you go there, you can see it has all the documentation that you need, right? And mostly what are the formats it supports? It has this many formats. So this will cover actually the animated models as well as static models. So the DEA is one, which is the collider, which is the most common use one these days. So we can load that directly without learning the structure of it. So we know the basic structure actually. So that's why I teach you object model. So that is what based on many things, right? So that is the structure most of these formats use. But you can see here, and they are also modifying this day by day, so you can get the latest if you want to compile, download and compile your latest one for the lib file and the DLL. Or if you're using a Mac, you can do .a extension with the library. So they're using a CMake to do that. So all the tutorial of how to install that and run it will be here, the installation, right? And basically they're using CMake to create things. Okay, right? So that is just a overview. So what I'm going to teach you today is how we're going to use this. So I will post my .lib file and the DLL if you want to use. Unfortunately, if you're using a Mac, you may have to create your own, go through the documentation and do that. Okay, right? So let's look at this. How we going to and how we going to code using Assimp. So that's what this lecture is all about. All right. So the first thing is let's have a new project. So let's go ahead and create a new project. Same thing that I used to do before. And then I'm going to set up in one of my setting paths. So this will be my Assimp project. So we call Assimp project. Yeah, you can use any name you want, but anyway. So this is where I'm going to set my common, and then I'm finishing that. Right, so it will give me the same old main, right? I'm going to use the one with mouse that I have in my website, right? So let's go ahead and copy that from the website that we have. I'm going to use structure with mouse, so Control A, Control C, and then I'm gonna paste that into my model. Right, so okay, so now I have that. I can run this and see what I get. Should get I think the purple window on this, right? That's what you used to have before, right? So uh, so then, yeah, so this is what I have. Okay, right. Before I proceed with it, I should have some libraries. So I will post these libraries on Canvas so you can download it. The one is called let's go and look at it in my common. One is called libassimp.dll. So this is one file. So if I have a DLL file, I don't need actually the lib file. Even I throw it here without lib, it might work with the DLL itself. So we'll see. If it is not, we can put it back again. So here it is, the lib file I have, assimp.lib. After you get that, once you download Assimp, so where are you going to download? Yeah, of course you can download it in the web page that I just showed you, and it will give you some include header files. I'm not sure whether you need all of it, but I throw it in there just in case. If the library or the DLL uses this, you might be throwing in these all header files. Why this many header files? Yeah, it will support, it will have so many things to handle, like 3D formats. Each format might have a different header, and also the lighting, and then also animation, timers, cameras, and stuff like that. So because of that, they have a bunch of things right here. And also this also supports skeletal model. If you want to use that, you can, right? So if you become expert on Assimp, you can use that as well, right? So where I'm going to place these things, right? So include one is in include folder, and I just have the Assimp library outside and inside the common folder. And yeah, maybe you don't need this. We'll run it without this and see whether it runs properly. Okay, I'm in the lib, the assimp.lib. Right, so let's get start coding. Right now I don't have anything, only the include file. So the first thing I want to do is put the those files and see how it works. Before I do the coding, I like to go one thing that I did not explain before. So let me pull out the Assimp structure and talk about that. Okay, let me address this before I start. You may have seen before, whenever you're using a model structure that we have. Oops, 1 minute. Let's take a look at the 3D model structure that we were looking at in object, wavefront object, and then we move from there. Okay, so in the wavefront object, we used to have of course V's and the VT's, and then VNs, right? And then faces, right? Usually you did not notice this. Some models have again V's, VT's, and VNs and faces, right? Why this group grouped it like this? Some part of this is like this. That means your 3D model, maybe it is the head part, is separate from the body part, right? Okay, so maybe the clothes or only the body, right? Maybe hands will be separated. So this part handles here, this part handles here, and then the legs and all that, maybe it's separated unit, right? Or if you consider a scene, actually you will have some tables, right? And the chairs in your scene, right? This is a chair and a table and a ball and a book and the lamp and things like that. So this is the whole structure of a room. So you can also design this model structure leaving it in one file, which is this will straight load a one whole big room, right? On the other hand, if you're using a joint with a skeleton model, that also have that kind of a structure. So you separate these items with a joint, and then you can use that as a skeletal model. Right? Any of these structures have children and the parents, so that's what the idea here. So the Assimp adopting this routine. Because of that, Assimp has some structure look like a little bit different than what we learn, but it also having a faces, normals and all that, but it breaks the mesh into pieces, right? So either it's called scene actually, in Assimp it's called scene. In this scene, you will have some root nodes, children nodes. That means you can break it into pieces and pieces like that. But everything out of these, all the units, actually will have the structure that we created by using object, wavefront objects, right? So it has vertices, normals, textures, faces, and materials if you're using a material. So we'll talk about this a little. What is this material? So this thing right here is nothing but that what we did. That's why I make you do projects on this to understand this one thoroughly. And of course the materials you can take as textures differently, but this one whole thing is handling by the faces to link each other. So this is the whole structure. So what one thing that we did not address up to now is this children nodes, how we going to handle this part, right? So that is the new only new thing that you're going to learn here, right? Okay, so this is what the Assimp structure look like, and it's also called the data structure of scene, and everything is based on scene. So it will have some pieces like this, and ultimately it will come up to what we did in our projects. Okay, right, so that is one part that I want to point out here. So let's do coding and see how this works for our criteria, right? So we're going to load some different models and see whether that works for us. Okay, right, so I will come back to notes in a minute. First let's do the basic setup and then create some sample program here. Okay, right, so let's move this one up somewhere so we don't need it anymore. And this is my basic code that I have. So I'm going to do some modifications here and do some alterations so we can use Assimp. So Assimp has three headings that we're going to use basically, right? So the first thing is, let's include that. So we're going to include it somewhere here. Maybe after glut I'm going to use it here. So you have to include few of the libraries, right? Include one of the libraries we called I have the folder Assimp in there, right? So the Assimp is my folder, and we have C import, which is you're importing the files from outside. So C import.h is the one which is handling any model that you're going to import to the system, right? So then the second one is you have to include another here. This one is called scene. That is the main Assimp structure. So Assimp and then the scene. So you need the scene actually. Scene is the one we creating all the things in there. Okay, so this is the scene.h you need. And the last one is processing, the post-processing. If you're using anything, constructing your structure from the format it's giving you, so that's called post-processing. So you have to process whatever the format is gives you you may have to do other operations on it. So that is the post processing .h that you need. All three, that's all you need actually. So if you set up your DLL and the lib, and if you have all these, you're good to go with the coding, right? So as long as it's like a soil.h, you put it in there and then you just start coding the same way that we're going to do for the 3D models, right? So yeah, I don't have the rotations and everything included here. I will copy and paste that part. So since I have it already created how to rotate things using a mouse and everything, we already done that part in few labs, maybe in your programs as well. So you already have that part. So I will copy that once paste that once I'm proceeding, otherwise it takes a long lecture without any reason, right? So once we have this, we will introduce a few variables. Okay, so what are the variables I'm going to put here? I will have something called the C struct. So that is the scene that I'm going to create. Okay, so we will have something called C underscore struct, right? C struct is already there because I included my assimp.h, so it will picking up automatically. Let's call it AI scene, right? AI scene, and pointer is just the instance I'm going to use. Let's call it scene, right? Just keep it like that, and initialize it to nothing in there right now, so it will be null for the start. Okay, so that is this is where everything will be come and set it up. So one more thing, the display list I did not talk about in OpenGL. One thing that you can do is you can create a one concrete list of things, and then you can use that as your display everything. So if you can, it's like a container that you can put all the things that you want to display in one container and call that display container to display everything in there, right? So it's just a bucket that you have all the objects in it. That's the way this program, sample program, handles displaying things. So let's have that. It's a good way of doing things. So it's called glu int, and yep, and then we call it scene list. So this is where I'm going to put everything that I'm going to show here. So I call it underscore list. Right now I'm setting up that to 0, so that means the handler. Okay, so the handler is that. One thing I need is a 3D vector, so I can use XYZ as my parameters. So the vector.h would help, but in this case, if you're using Assimp has its own. So let's have that one. Underscore, C underscore structure again, C struct, right? C struct, we have something called AI vector in this one. So we're going to use the AI vector 3D instead of 2D, right? So what are things I'm going to do? Well, a few things I need is the bounding box. Why you need a bounding box? Well, let me talk about that for a minute here. Why you need a bounding box in this case? If you remember, I just talked about my when you're having a 3D models to load. One of the 3D models is my rabbit, right, or the bunny, right, and the other one was Atenium, right? So this is a model of face like this, right? Something like that. Okay, so these are two different things that we loaded. Remember the XYZ values on this one, right? This one has 700 huge numbers, like, right? This one had a lot of big numbers, right? And also we had a cube, which is XYZ on the cube, that has very small numbers, right? Like 1.0 to 1.0, like that. So you can see the difference, right? So if you display this, it will be so big, and if you display this, it's just very small. So you have to find a common ground to display these things. So what you do is you put this in a bounding box. Okay, you put this in a bounding box, and then what you're going to do is you're going to use this bounding box to scale your object. So if you have a bounding box, I can scale it down or scale it big depending on your viewport. So this is very important to have the bounding box for each and every model, because the model sizes are different depending on how you create it, right? So that is the one thing that we're going to consider when we're using this kind of format in order to make things work. Okay, so let's look at that in a minute, how we're going to create the bounding box. So let me create some variables here, and then move on. So what are the variables I'm going to create? Well, scene minimum, scene maximum, and the scene center. So that is one thing that I want to do, is the mark down the area. So those are my my limits of my scene. So it's a scene min. I have here scene max, the maximum size of it, right? Scene underscore max, let's call it like that. And then we'll have a center of the scene. So you define the center of the scene as well. So scene center. Okay, so those are the things I'm going to set up as bounding box. So it is XYZ values you have on all three. So that's why you have the AI vector 3D means, right? So it has its own data structure. You know how to create these, right? These are nothing but the type def structure. Then you will have these values in there, right? So that's what it is actually. Okay, so that's what we're going to use in this case. Okay, then so let's define this one. If you never use this kind of definitions, that would be pretty interesting to know. So this is one they're using, and which one is bigger, which one is smaller. So instead of writing an if statement, I will do the shorthand writing of y. I mean y here. If x is bigger, if x is big, if it's less than y, the minimum value will be x value, or on the else, in the other hand, this will be y value. So that's what it means. Define again, right? And AI side, and then we take the max, right? And then we take x and y again, and you say the same checking here. So if the x is greater, I will put x value, otherwise y value. So I can write either way. I can say like this, right? Question mark, and then I can say if it is the case, if this is the case, if the x is less than, y is less than x, actually, if y is greater than x, I pick y, otherwise I pick x, right? So it is I don't need semicolon because it's a definition, so I'm using that here, right? Okay, so now I have these things, but one thing in this program, I'm actually going to use the material. So this material will, this part right here, we setting up the material depending on if it is a shiny ball or the metal. It should have a different material than any other object. So instead of I'm setting up a material for everything for this structure, I can ask the model, like for example, if you putting a marbles has a shiny model, shiny looking objects. So if it is really dull like a rock, it's not shiny that much, so you should not put the shininess onto the rock and things like that. So that is what it's handling by the material, right? So here we are setting some materials on this program. Since we're going to handle this by Assimp, you don't need this part. Okay, so I'm going to cut this off. So you don't need that. Obviously, if I compile now, it will throw me errors. So anyway, I'm going to handle that deep down there. So yeah, so we'll handle that. Well, yes. So okay, so let's go ahead and write some functions. The first function I'm going to write here is my bounding box. Okay, so let's put it here at my program on the top. We're going to handle the bounding box. Why the bounding blocks are there? Well, that is what I don't need this handle callers here. So let's get rid of that. So I'm going to create a bounding box here, right? So it's void. Well, the get bounding box, get bounding box, yes. For each node, actually, each node means each child, whatever you have. You can do this. So for node, we can call it, and then what you get here, well, the constructor node, I mean, we have to have the node of that we're taking in, and what is actually doing by these two lines right here is if my x is so when you proceed with your vertices, right? So if you get one vertex, and if that vertex is bigger than the other vertex, I throw that to the minimum value, right? So what you're doing here is actually, let me write it down. It's pretty interesting way of finding the max and min. So let me explain that. It will be great. So let's say I have x is 5 and y is 10, right? And again z is something else, right? So then again I will have x is 6 and then y is some other value like let's say 5, things like that, right? So whenever you get this, you will filter out what is the maximum x and what is the maximum y. Why you need that? Well, if you put this thing in a one box, right, at the end, if you have your object here, right, the maximum x and maximum y, I will record it down. So I can define each of these corners using that concept, right? Okay. Right. So yes, you need to know what is the maximum x, maximum y, and all that. So that is what part which is handling by these two. So it will detect which one is maximum value, which one is low value. Depending on that, you can create the bounding box. Okay. So this is the idea here by defining those values. Okay. Right. Okay. So let's move on coding on this, so we can get over with a lot of coding we have to do here. Right. So there are a few things I'm taking in here. One is the structure of the node. So it's just a pointer. Let's call it constant c struct again. C underscore struct, right? And the node is that little child you're taking in from the tree of scene. So this is a node of that, and we call it nd in this case, right? And yeah, I have to take the minimum vector value, maximum 3D vector value, and then the matrix of the values. Okay, so those are three things I'm going to take here. So I will use the c struct several times. So let me write it down, I mean copy it down and then paste it here. So 1, and then I have 2 for this, and then I have 3. So these 3, I'm going to take one value I'm going to take is AI vector 3D. All are like this. So this one is also AI vector 3D. And for the fourth one, actually I'm using a matrix 4x4. These are the inputs that I'm getting in for the bounding box. Okay, so this is matrix 4x4. structure. All right, so give some names for the variables. The first one is minimum, next one is maximum, so we call it max, and the third one is I'm going to take is transformation matrix, so that's why I'm not considering when you take this value right here as a matrix form, you don't have to worry about having transformation. So it's just only the way you see, you just handle that size structured into the scene instead of having a z depth. So that's why you don't consider z depth in this program, this function, when you come to the bounding box. It's always converted to 2D version of it. All right, by using the transform matrix. Right, so let's write the structure here. So you need the previous matrix and the current matrix whenever you do the transformation from previous to the new. So we always going to handle the bounding box for the scene. So what I'm talking about here is so when you going to do the bounding box in this case, actually what is it showing you is always whatever the screen that you see here. So if you have an object here, right, and I'm going to set the bounding box only for this, right, this much, right. So if you rotate this one, for example, that is a transformation you do, so then you might have different scene. Now it will be look like this, right. So in this case, if we rotate it like this, again you're going to handle that the display on this depending on the 2D. So it is the bounding box of this actually, and the rest is like that. So it's always going to handle your bounding box depending on the size. So that's what one thing they're doing in this bounding box. So that's why it's always a 2D bounding box. Okay, so that, for that reason, I'm just having this matrix here, which is a transformation matrix. So let's go transformation instead of tro for. So let's have A here instead of F. Okay. All right. So we have that. Now we might need a local one more thing to store the previous one. So I will have the same kind of a structure here. Actually, I have to have a pointers for each of these. So let's have pointers of these. So we're going to create classes, instances, class instances. Right, so those are pointers to these variables. Okay. And let's have one more. In this case, I can store this. It's not supposed to be a pointer. In this case, I can do this. So why is that these are pointers and this is not? Well, usually when you're passing data from somewhere else to here, you pass by reference. So that's why you have pointers here, and you don't use pointer here because I don't want to pass it like that. Right, so it will be only for my local use. Right. Okay, so then what you're going to do is I will have two more variables I'm going to use here. One is unsigned integer, right? Unsigned integer I'm going to use as n, set it to 0, and then another one we'll want to use here is t. So we'll talk about that in a minute when it comes to coding on that. Right. That t is the counter actually. I don't have to define it here. I can define it in my for loop. Yeah, just do that. I don't need this t here. Okay. Usually I can use a for loop for this. For both of them I can use a for loop actually. But one thing is when I'm using int, I'm not going to initialize it. If I initialize it here, so I will use that, and you don't need the t part. So let's get only n will do. So n is enough. Okay, so let's go and move on. And yes, the first thing you have to do is you take the matrix and transform that to the one that I'm using here, which is I'm going to use one matrix um, from this node transformation. So whatever the node is giving me, I'm going to transform that and use it as this variable right here. Okay, so I'm going to multiply this to this and get the transformation matrix. So that's what I'm going to do. Right, before you do that, I will take this guy and store it as the previous matrix. So that's the first thing I do, because I'm going to alter this one with my transformation on this object. Okay, so the first thing I have to do is get a copy of this and store it in my local variable. Here I call it prev, right? And that will be equal to pointer to my transformation. Okay, so that's what it is. Yeah. Okay. Oops. Transformation like this. Right, yeah. So that's what I'm going to use for. Okay. So so now I have copy. Now I modify this. So I multiply 4. So this is the one I'm using to multiply matrices, and then I'm going to do is I'm going to alter my transformation matrix right with uh, the node transformation. So the node transformation is nothing but transformations in the node that we're going to read, right? So especially on animation this is important. So right, okay, and then transformations. So this is what M transformation is, right? So we're going to use that. Okay, so that is the final look, whatever is in the 2D after this. That's what we're going to use. Right, so since we have already defined the n is here with a 0, we can do the for loop here. And in this for loop, what I'm going to do is I'm going to set up my the sizes of the boundary, right, on the boundary box. So it will return actually the boundary box at the end. So I'm going to pass some values in there and then get out what the matrix is going to be on the 2D screen. Okay, right, so let's take n less than the number of meshes I have. In this case I will run for all the children I have, so it is a m number of meshes, actually m num meshes right here. So that will return you the number of meshes I'm going to handle, and then n is going to increase one by one, so that is the limit that I'm going to do something. So that is under the bracket again, so I call this yeah, so I'm going to call this n4 just in case if I miss where the bracket is. So okay, so then let's do this part, which is I'm going to create the max and min. Actually, that's what I'm going to do here, and then I'm going to store the maximum value and the lowest value, so I know where it is, where is my bounding box for all this. So that's what actually this process does. So instead of I'm typing the whole thing here, let me paste it because I have done this already. Okay, yeah, and then that will be easy. Anyway, you're going to post this screen and use the same. So I will copy and paste this and then talk about it. It's much easier than I'm just typing everything by step. Okay, so let me get this here for yeah, in this for loop and the other one. So let me take care of this part, which is I'm going to get from here. Yes. All right, I'm getting this from my previous code that I have written, so that's why I'm just pasting it here. So Okay, so what you do here is actually the t, you don't need the integer t because I don't have it. Int t is defined. So structure, constant struct of mesh multiply mesh pointer. So this is what the mesh is, the final mesh, and that will be the scene meshes that I'm going to use. Is the children part of it, so I'm going to store it here. And I know the vertices now because of that, so the mesh has a number of vertices that I'm using, and I'm going through each vertex and find which one is the greatest. So I just showed you that part in the example just a minute ago, and so I'm going one by one, right? So you may notice I'm starting with 0, and then even I'm starting with 0, I'm having a plus plus and not a t plus plus. So plus plus t means it's starting from 1 already, even it's 0 starting, right? And okay, I'm putting my vector into the 3D 3D this is xyz values. Even if you're having a long name for this, this is nothing but vector 3, so that's what it is. Okay, and then it's called temp, and then I'm putting the mesh vertices there, and I'm applying the transformation. So whether I'm seeing it or not, that's what I'm checking here. If it is my screen which is showing things, then it's setting up my minimum and maximum values using that definition up here, which is if it is x is bigger or the y is bigger, you're checking that, right? So you're checking the existing minimum and see whether the new x is bigger than this guy or not. In this case, either the new x is smaller than this one or not. If it is smaller, you assign it. Here as well, so you compare these two and apply that, right? And here as well, you compare these two and put it there. There you go. So now here it is xyz. It comes into xyz values. Okay, so yes, so this definition actually up here is you take two values and compare. That's what it does. So you don't need z here. Actually, you have the z here, right? So keep a note that I was talking about that earlier. So here it is. You have xyz. So you have the whole bounding box, and then you using a transformation to see the angle anyway, right? Okay, so now you have that part. Okay, so this is now the bounding box, and yes, I can do the bounding box. I can do this for all the nodes that I have. I can walk through the structure of this going one by one, right? One scene by one child with the other. I can do the same thing. So because of that, I have to do this part for all the pieces I have. So in this case, I can recursively call the same function again in order to make this for all the children I have in my object. So let's do that part, and so this is what I'm doing, that for the all the children I have in my structure, right? So let's go ahead and do that. So for n equals 0 and less than this one, this is how many children I have, starting from 1 instead of 0. So that's why this is equal, even the plus plus n. So I'm calling the same function which is this one, right, for all the nodes I have, and I'm calculating the bounding box, right? Because that's what I'm doing here. And then yes, you can store this. Why you need this one here? Well, so let me talk about this for a minute. So why you need the different pieces here, I mean different why you have to do that for all the nodes. Like let's say I have one structure here and I'm calculating my bounding box of this. So this is the bounding box I have. So let's say I have another piece here which is a hand and a leg, right? So in this case, yes, you have to consider the bounding box. So after you process this one, your bounding box will be this size instead of the one I have, right? And then if I process this part, my bounding box will be now this size. It's a little bit bigger than that, right? And also there can be another child which is a smaller, like a nose separately. In that case, its bounding box is small. It won't count because I already covered that by my bigger size. So in order to uh, allocate the right size for this guy, you have to take care of this part right here. Okay. Right. So that's why, yes, that's why you have this structure of a recursive call in here, right? And then you can handle it better. Right? So that is that we're reading here. Okay. Right. So after this bounding box, and then applying that for all the nodes that I have, then I will move into the conversion. I'm converting a few things here, uh, uh, and then I'm getting the bounding box for each time. If I want, I have to call this function and get the bounding box for the displayed version I have. So let me put that part here. Why I need these transformations? Well, let's say you rotate your object, right? After you rotate your object, you should have your bounding box also rotated, right? So that is the one reason I'm having this transformation matrix everywhere. What I'm saying is, like, let's say for example, your object is now like this, right? And my bounding box is look like this, right? So I generated my bounding box for this guy. It's good. So if I rotate this object with another angle, right? So let's say now it is look sideward like this, right? So now the bounding box is changed, right? So maybe he has a stick on there. So now bounding box size is changed. So whenever you rotate this, your size of a bounding box has changed accordingly. So this is something that you had to address, right, to the transformation. So one way of addressing that is we calling this function again with the right matrix in it. Okay, so because of that we have to use another function in order to handle that. So let's use that one right here, which is called the get the bounding box. If you want to get it and play around with it, especially in gamings that you might need bounding box for that. So, or just get the measure. So this is what it is, get bounding box. So we have the 3D character again, and we have minimum value and we have maximum value, right? So those are two things. I took it from here and pass it here, right? Minimum and maximum, right? And then the structure of the transformation, okay? And then initializing the matrix with the load identity matrix, right? So GL load identity is the same thing that has here, and then you will initialize your values here. So this is the initialization, and then of course I'm going to run the same thing I here to here, so it will be set up the right values. Okay, so this is where you just calling that function and store your values for the bounding box. So this is what it is. Right, so you anyway what you're doing here is creating a matrix of 4x4 transformation matrix, and then obviously you're going to do the rest, calling this function here, right? Okay, so that is the execution of bounding box that you created here for the node, and then you put everything together and get one big bounding box right here. Right, so then there are a little bit color conversions. You take especially for the material and all that, there's a color conversions application. I mean the function which is doing the color conversions. So let me show you that part, which is nothing but you take some floating values and you convert it into one array of data. Okay, so how do you do that? Well, those are very baby things that we just using here as well. The void color 4 to float 4. So if you have colors that if you want to convert it, I'm using a 4D color conversion, and then I have the float array that I want to return. So this array will store the color that I get as C, right? If it is R, I'm going to put R there, GB values, whatever the value I have, I'm converting that to float number and put it here, right? This is also the float numbers. If you have, you put it into one array. Why you need this? Well, you need this for the actually the materials that you're going to use in this program. And this is just a simple conversion functions. One is set floating 4. One is a color 4 to float 4. The other is whatever you get as a float, and you just put it as a 4. You can define this or design this as type def structures if you want, and use that also. But in this one, it's pretty lame and straightforward with how you do that. It's not big impact, but anyway, that you can use it, right? Right. So one thing here that we're going to use is a load set, that is the scene with the maximum and minimum values, and then also we're going to set the center. And how we going to load our objects into the scene. So this is the load set function, especially for the presets that we're going to use, right? So this function is doing that for the scene maximum and minimum values. So well, this is on the documentation. Actually, it is a simple sample that I'm picking up here and then showing you. So this is where you get the bounding box, okay? And in this bounding box, you have the scene minimum and scene maximum that you're going to set up, right? So you know the scene size now, right? Okay. So using that scene size, of course, I can find the center of it. So this is how you set in the center of your box. So anything that you're going to display on your screen, it will place onto the center if you're using this, right? So why are you dividing by half? Well, if you have maximum and minimum, and if you divide it by 2, that will be the center. Why? Well, in our code, actually, we have our Cartesian coordinate system like this, and the center is 0, and this is the maximum value, and this is the minimum value. So the center is the middle right here. So whenever you using something, it will display on the center when you're using this function. So that is the load set function is doing, is setting your center of your object. Okay, so that's what it does. If your scene is axis, of course you can do this. Right, so that is something I don't have to worry about much, but you display everything on the center using that function. Right, so the material function that we used here in my initialization, I have these values, and we call this function material, and then we put the GL front, ambient, diffuse, specular, and shininess. So these are the things we set up as a material. So if you never notice this is a function which is setting the material. So in order to do this in Assimp manner, especially when you're designing an object in the models, usually the model designer set up the material for that. Okay, so if you're using a Blender or Maya 3D or whatever it is, they have their own way of setting the material. So we going to write a function for that in Assimp, so you don't need this part right here. Okay, right, instead of this we will have a new one which is called the setting of our the material structure. Okay, so we call it apply material. So that's what we're going to use here instead of what I have. So let me put that one. This is the part which is we handling all the materials that we have. Okay, so let's put this one here instead of what I had in there. So let me paste that here. and talk about this one for a minute. So the apply material. So the constant C structure AI material. So MTL, you may have seen this one in some original wave loaders has this. Okay, so it's called uh, applying materials here. Okay, so then yeah, the float C4 is just to a variable that I'm going to use here because I will use conversions. Okay, so that's why I'm having that. And these are the things that we use: the shininess, emission, ambient, specular, and diffuse as materials. So that part is already x, y, z, and w, so that's why it's 4D. So or we can say vector 4 type, right? So that's why we have that. And you want to have two-sided materials? The wireframe we talk about here as well. And the maximum value, or the maximum value here, we'll talk about this when I proceed with it. Okay, so the set the set 4 is for the color, right? So there are the values. I'm going to put it as a C, and then I'm going to use C. So that means what? I'm using 4 colors on my material. So remember that we had it like that too, and we're going to put that in a one array. So that's what it is, a C array. Okay, and we after you put that, so it says this is error check whether if did it get diffuse from the load model, right? So this is you just check whether it's it model, and if it is exists, of course I'm going to convert that to colors, right? And then I'm putting that in the material. So that is those 5 lines I wrote in initialization. The same thing you do, and you just take the values from my model and then put it there by this call right here, right? So that is a specular, and you do that for the ambient as well, and you do that for the emission. We did not apply emission on our model, but emission is something also that you can use, right? And so there's a parameter called max, always setting up to 1 when we're talking about the material float arrays. So this is something especially in the shininess they're using in a different form, right? And there's some programs they're using on AI, means that they're using in Assimp. Okay, so everything AI means Assimp function. So anyway, here it is, they're calculating something and test with the shininess, whether is it over maximum of the shininess value here. You set the maximum value of shininess to 1, and see whether is it less than or whatever the strength that you're using. Depending on that, you apply the material here. So that is a little condition on the shininess they're checking there. And else the materials for the shininess that you're using, whatever they have given, and the specular as well. So that we have specular, shininess, ambient, emission, all this applying here. Okay, right. So that is the wireframe. Remember that we have in our code, which is in my display, we have this right here. This is how I decide whether I'm going to display a wireframe or not, but they have different way of taking care of it. Well, I don't want that one. We will talk about that in a minute when we are filling this part. So this is how they're handling it, right? So it's a GL fill or GL lines, whatever, depending on what you have. So yeah, I can use my code and then use my wireframe instead of there and applying that. So we'll talk about that also. Why they're having it here? Well, some models, model loaders can set it up as a wireframe instead of a fill model. So in that case, when you're reading the materials of the structure, it will tell them which kind of a model is it. So that's why you're having that. Okay. Right, so now so far I did a little bit quite amount of coding here. So let's compile it. If I have errors, I can make sure if there are no errors in it. Okay, because we have done a little bit more. So yep, there's one here. Talking about n, so let me check that and then fix that and come back. Okay, so I can see I have one bracket here. I don't have the other bracket to close it, so I have two for loops, one here and one here. So this is also end 4. I did not have bracket there, right? So it is end 4, obviously. Two for loops, and that is what one thing I have. So and then another one here. That's the function name, the same name, it has to be up there. So that is that part. I think that will take care of that. And then we come here. So in this one we're going to talk about the scene. So let me take care of this one as well. Let's talk about constant. Okay, I have to put constant at top here, and I'm using my, yeah. So if I set it constant, so that to take care of it, I guess. Let's put that and see the constant take care of it. Seems like it's good to go. Right. Okay, so let's move on. So now only thing I had to do is display this, right? So I set up the bounding box, and I set up some apply material on it. And oh, one more thing in the material I just not address is the last part here, the cull face, right? This cull face is actually taking care of the back side of it. So especially if you're using a glass kind of a material, you may have the cull face enabled. That means you can see that transparency in it, right? So disable means you can see everything solid. If you want to see the transparency, you set up cull face enable, so you can see the back side of it, right? So that is one more thing I had to address there. And then only thing I had to do is draw this, right? So then draw it, and then yeah, so there are two options for this. I'm going to draw one child at a time, and then all that differently. In that case, what I have to do is I have to actually do this, the recursive function to do this. Okay, so in this case, let me handle the display in two functions. So one function I'm going to use is recursive render. So because I'm going to do child by child, so let me put that up here and then talk about that, so I don't have to type all of it. Anyway, I'm going to make this available for you, so you can go and look at it. You can download it and play around with it. Okay, so this code you can, I will put it up there. Right, so this is what the recursive render means. So that means I have to go with each child and do this. So the recursive render here, I'm using the scene, I'm passing the scene, and I will have my node structure, which is nothing but ND. The node is each child. I'm going to go and get, and wireframe mod passing here as well. This is the wireframe or not. So if you want to use the wireframe, of course you can use that value here or not. Now I think I'm using this one. I don't have to pass this if I'm setting up in a global up there. I think I already have it in the global. But anyway, what I'm doing here. So this is actually if you want to use the keystrokes for the wireframe or not, instead of having that from the model up there, you can have a little control by yourself. So this is where you do the rotations and all that. Most of it you can use here. So let's talk about this. So now I have an integer counter, and obviously other n and t's that I'm going to use as integer counter. So these are only integers. Right, transformation matrix is important because I'm going to do rotations and all that. I can do it here, I can scale it here, or I can do it on my other display as well. So update transformations, so we'll have matrix. And why you need this? Well, if you're using animations, this will be helpful for you. Okay, so that's one thing they're writing this one. include the animations as well. So the transformation is very important when you're doing the animation. So that's why you have it in this render, recursive render function. Obviously you put everything in a one matrix, right? And so then using that matrix with the transformation, so you're multiplying, then you can see the angle, whatever it's designed by this the designer. And then for the number of meshes, so this is where the children comes in. How many pieces of meshes using? If it is one, yeah, you have only one face unit. When group of face units, otherwise you'll have plenty, right? And then we put the mesh, the scene into a mesh, so whole thing will be created as a one mesh, right? Instead of you have pieces. And then you apply material. So the materials we're gonna apply right here, right? All the materials that I want to put as the initialization. And here checking whether did they provide normals for your object. If you do actually you can use that. Otherwise, if there's no normals, then we just don't need the lighting as well. If you have normals, obviously I have to enable the lighting, so that means I'm going to show the lighting, right? So this is decide by this whether the normals are there or not, right? And then obviously you can change these to the way you want. This is the general structure, right? And then the t, because I define t as an integer here, or you can actually define it here if you want, until you get the number of faces, and you will go through this structure and the faces that you're going to store here, right? So now the good thing is, what is Assimp actually doing is it will take all these different formats. So let me address that for a minute. What is Assimp actually doing, right? There is one thing that I want to point out here. Let's say you have different formats, like for example I have so let's say DEA Collada model, and I have 3ds, which is 3D Max model, right? Or a blend for the Blender model, right? And or like the object models. So like that, so many formats out there, right? These formats we don't know. So what is this guy do is they take all this in and break into vertices, VTs, VNs, and the materials, of course, and then the Fs and the texture, the faces and the texture, and also the materials. And if you have a camera setup, you can do that, the cam setup, and the lighting, of course, if you want to do that, right? So all these parameters, they can handle it here. And then the next one is just putting those things in variables, faces, and all these. So this is where the buffer comes into play. So this buffer also they're constructing using these things. So you have a way to handle it if you want, by your own way of doing this, or you can stick with the standard, whatever it is. So this is the part actually the Assimp does, convert these things to one data structure, and this is data structure we can handle. We have flexibility right here to do whatever you want to do. This part is one which is Assimp does. So the Assimp do a good job on this, and then how you're going to use this is up to you. Okay, right? So this is the structure, and this is what we're going to do in this program, right? Okay, so let's look at the first thing you do is here the number of indices. So we actually they have only 4 options here. Default is you draw it as a polygon. Either you can draw it as a triangle, line, or a point. So yeah, so all the things that you take, you will check the mod that you want to draw it, right? So that is depending on actually the model that given by the designer, what type you want, right? So that's the beginning. The face mod is whatever the GL begin, whatever this value is that you're going to use. and then we'll have number of indices. That means the same thing as a VBO, remember that. So that's the same thing. And then we take the index value, and then we apply the colors and the normals, right? So this is a GL beginning structure, right? Either you can have a draw arrays. If you want to do that, you can extract these and put it on your own VBOs and then play around with it. Right here is just drawing it, the structure, the same thing that you did in your projects, right? Okay, so then you execute the vertices. So this is separately drawing each of them, right? If you want to use your own buffers, you can put these things in there as well. So here it is very simple structure that they're going to draw it, right? And then you move from one drawing to the other little pieces like this one, right? So like this one, I want to draw this, and this. So all the pieces I want to draw. So in that case, here I have another little small thing. You travel to the children and you recursively drawing things, and then you pop it up. So that's very straightforward from what you have done before. So that is the same thing you do here as well. Okay, right? So then yeah, so then we go and draw this. So we have our own display. This is where I'm going to call this function, and well, let's go ahead and look at it, what we're going to do here. Let me apply some few things. I did not rotate this, so let me add some rotations, transformations that I'm going to use before, right? So yeah, so let's have a few things I'm going to apply here, and I'm going to set some values in there as well. So let me paste these things, which is a GL transformation. You have done this before. And then the rotations that I'm going to use, rotate X, rotate Y, and then also the scale. So this scale is my own scale that I want to put, but I forgot to put these variables up there. So let me have those variables defined up there, otherwise it will throw me error, right? So let's have a few more things, the old mouse, because I'm going to use the mouse functions in here as well. So let me have that from my previous labs that I have done, so you can do the same. So you need some variables here. I'm going to put this in a global area. So these are things I'm going to use. I'm going to use the mouse function to move it around and things like that, and the mouse button, and then the rotations right here, and the translations right here. Yep, I need one more for my scalar, right? And so let me have that one as well. So I'm going to use some scalar value here, right? So that is what we call TMP, I think, in there, right? So that is what. Okay, so now in my display I have those things, right? And those are how I'm going to handle those. And then I'm going to draw this as a scene list. So remember that we created something called scene list here. So that means everything in my scene I'm just going to display now, right? Where is my scene list? Right here, right? So this is what the function I'm going to use to draw things, right? Alright, so let's go down and call scene list in my display right here. After this, I'm going to use that, right? Okay, so right here I'm going to use that. Okay, so let's if the scene is the case, and so this is how we're going to display this. I already have that in my function, which is render function. So I'm going to recursive render. This is what we calling it under the scene. And the scene list is if the scene list, this is the one list I have showing, so it's generated that list, and then we call it a new list compile. So that is the only thing that we're going to use here. This is one part that I did not cover. You can read about it. It's just setting the list of displaying things. Okay, so this will a good way of organizing the memory. But simply what you do is you just call this function, Right, so that's all you do. If you don't want this, any of these, you just can simply call this recursive function. That will work here, right? Obviously you need a swap buffer, and then GL call list each time after you create it once. Only thing you have to do is call it each time. Okay, right, so that is how you display things. Let me address few things on my the other part, which is I want to make sure I want to zoom it, zoom in, zoom out by some my own values that I set up. So let's create that one, and I'm going to create that one here. Let's go ahead and do that. Right, okay, so I have case 1, translate, make it zoom in, zoom out, and then going to display. Right, so these are switch cases. Since I have a switch case ends there, I don't need another switch case ending here, so I will have it in this form right here. Okay, and then I might have a special keys that I want to do some rotations using keys. I don't have that key program here, but you might have it in several programs already in the lab. So let's apply that. So this one is a special keys, right? Translation, I'm using a 1, and the key up, key down for rotations, and left and right. So this part already you have done in the lab before, so I'm just applying that. Oh, you did it in the projects as well, right? And then I'd like to apply some mouse as well, right? Idle function I'm not going to use here. The mouse functions I have here, what I have in the mouse, so let me go and look at it. Right, this is my mouse, and yes, the scaling is 100 on my resolution. If the GLUT down, I will do something. If the GLUT up, I'll do something. So let me copy this again. Don't want to write this part, so just have that here. Once when you're doing this part, so let's take care of from here. Okay, so let me put this one, paste it here. So what I'm doing here is get the scale size, and then this is something I'm doing locally in this program only. This won't match the proper proper coordinates for mouse unless you apply the transformation matrices, but this is okay for this program, so that's why I'm using it. If you want to accurate clicks, this won't help actually, unless you're doing a GL auto, right? Okay, anyway, these are mouse button things that you do. We have done this before, and then I don't need this semicolon right here. That's something weird. Okay, so that is mouse, and then the motion is I can apply moving things with the motion. So let me put that over here. This helps you to move things, right? So it is also there. Right, when you're applying for the initialization, right here I have to load the model, of course, right? So the call phase, I was talking about that, and these call phases I'm going to take care by the model. So model loader, you don't need that, and clear, of course. And I have to create one structure which is called the loading these things. So how do you load things in using Assimp? I need this variable right here. So what I need here is this, right? So this is a stream, which means I'm going to load the file from outside, so that's why I'm using this one right here. Okay, and the normalization and the column materials, yeah, you enable those. Again, you can handle that by the system if you're using a loading a model. And depth test, yes, I'm doing that. The color lighting, we'll leave it like that for just for this case. you can change those if you want, right? uh, but still will work by the model. So but anyway, I don't want to change those things right here. Okay, so now we come to the Assimp part. So I create something called stream, right? So now I'm going to get the stream from what is the Assimp suggesting you to do. So I will copy that part straight from the example that they have. So let me show you that. So what you do here is you take actually I'm going to write output as well. So this is what I'm doing here. So what you did, it is Assimp log txt, that's where you're going to write things. So it is right, and then the load asset. So this is the only thing that I had to worry about. I'm going to load something here, so and then see how it works. So let me have one of the models that I have already. I don't have any other models here, did I? Well, let me go and check. Well, I'm writing this project called Assimp project, so that is the name of it right here, but I don't have the model. So let me have some models in there. So I have previous models, few of them here. I'm going to copy that. Make sure you have your own models as well when you running this, right? Okay, so I load that model sets here. Let me see what I'm going to get from here. Okay, so let me get whatever you have working on, right? So maybe the bunny, maybe some other format. So there are so many other formats here, so you can take anything you want and play around later on. I have a few things I tested here, right? Let me get when model right here. Yeah, so for now let me get one. Okay, so yes, so yeah, anything that you want, any type of objects or any other formats you can use, right? I think the new ones, I have a little bit of DLL, which is the old one. Probably I will compile and post the new one, but if it is not, we can use this. So yeah, so that is how you load things, and then here is you setting up your the scale size depending on what you're using. So this is the temp that I get. Temp means what, the temporary size of my scaling, which is I'm using the translate on my case in my display right here, scale temp. How I created that? Well, this is where I'm taking the values from. So I'm taking the values from here, which is my scene actually. Okay, right. So this is how we calculate that to set it into your screen size properly, right? If it failed to do this, obviously this is where you ending up with, and then you setting up I don't need this diffuse thing, I'm already doing that over there. The color materials, right? Diffuse, I don't need that. Okay, so now pretty much I have that much for my initialization. One more thing I had to do is the files I created, special keys, mouse and mouse motion. I did not call these in my main, right? So I had to call it. Oh, I have the, never mind, I don't have the mouse motion, right? So that's the only thing I don't have it in there, right? So let me copy that, and so I did not have mouse motion. Let me check whether I have two special keys in that case. Right, I have mouse motion, I have mouse, I have idle, I have special keys. Yeah, there are two functions for the special keys. It will throw me an error, so now I'm good. Right, so everything is look alright, and let's compile and do a debug and see what many errors I get. Right, okay, if it is not errors, that's good. if there are errors. Oh, I did not get any errors. I hope it will run. Okay, so it ran, and this is what I get. So number one, to zoom in, zoom out, I can rotate it, I can move it my mouse, right? So this is the structure I get. Oops. And one thing I did not get is how do you really going to have my wireframe. So that's something that we can handle here. So let me check whether I can do the wireframe. Okay, so now my wireframe works, right? So in that case I can shift from my wireframe to this, and also the system can handle it by its own as well. So yeah, this is the structure of things that you can load straight ahead from the Assimp. So Assimp work without the funny thing here is I had only the DLL file, right, which is loaded in my folder, right, but I did not have when you go to project and properties, and then if you go build options, I did not have it here. Oh, well, I'm not sure that I installed it to my Ming GW. I think I did. If it is not, you may have to call it here as a .lib. Right. I'm not sure whether my system supports already the Assimp. Anyway, I'm going to post assimp.lib as well as assimp.dll. Let me know if you have issues. It's not running on your system. But anyway, so this is a very basic. It's similar to what we did. Only thing is we calling a few libraries here, and then we thoroughly take care of the bounding box. That was one part of it. So but anyway, what does it do is you can load any type of model. The advanced level of this is how you manipulate the animations by giving keys and all that, so with the timer and everything. I did not talk about that here, so you can go on Assimp tutorial if you really want to handle that by keystrokes, because you have to set up a timer as well in order to do the animations. Okay, so but the animations is straightforward. Only thing you have to do is set the timer and then the one function for the animations. Okay, so I have seen some tutorials out there, you can use that, so you can make them actually running around. Okay, right, so this is a very basic Assimp tutorial, and I just want to show you it is very simple and similar to what we have done, because the Assimp will convert everything to the form that we have done our projects. So in that case, now you know what's going on inside. Without learning those projects by yourself, if I give you or teach you this one, you never get it. So now if you did your projects by yourself, you know what are the vertices, normals, and faces, means. So in that case you have a clear idea what is this Assimp does. Okay.